Board November 2025. Refer to the diagram shown. Calculate the value of W or in kilonewton per meter based on the following condition. Number 1, if L or length is 8 meters, moment at A is 8.96 kN meter, moment at B is 13.44 kN meter, R sub A or the reaction at A is 5.04 kilonewtons and R sub B is 11.76 kilonewtons. Now this reaction RA is the same value for V sub A and RB is also equal to V sub B. Number 2, if L is 6 meters and V sub A is 9 kilonewtons. And number 3, if L is 10 meters, X is 5.477 meters, and maximum moment or M sub max equals 25.727 kilonewton meter. Number 1, if length is 8 meters, let's start with number 1. There are a lot of given values here. M sub A, M sub B, R sub A, and R sub B. So I can also think of at least 4 ways to solve this one. Okay, so since this is the board exam, examiners are expected to have memorized already the different formulas for fixed end moments. For this particular case, our moment MA is WL square over 30 and moment MB is WL square over 20. Like this one here. These are the fixed end moments formula for different cases. We'll be using case number 5. In this formula here, we can see that it's negative W sub O L square over 30 and then MB is negative W sub O L square over 20. It's negative because the assumption, the derivation of this formula, the bending moment at A is assumed to be clockwise while that of B is counterclockwise. In our problem here, it's the opposite. Moment at A, according to the figure here, is counterclockwise and moment MB is clockwise. So I'll just use the positive values for MA and MB here. For number 1, I can use the formula for MA, which is WL square over 30, where M sub A is equal to 8.96 kilonewton meter. So if I'm going to solve for W is 30 times M sub A divided by L square equals, and L is 8 meters. So W is 30 times M sub A divided by L square equals, let us express this in kilonewton per meter. That's 4.2 kilonewton per meter. That's letter A, this one. I can also use M sub B here. Since M sub B is given, M sub B is 13.44 kN meter. The same length from the formula, M sub B is WL square over 20. So let me copy this. This becomes 20, this becomes MB. So we will still get the same result, 4.2. Another solution would be to sum up vertical forces because we're given RA and RB, and the sum of RA plus RB should be equal to the area of this triangular load. So that means R sub A plus R sub B should be equal to 1/2 times W times L. We're given R sub A equals 5.04 kilonewtons and R sub B is 11.76 kilonewtons. So W is this sum, and that will be times 2 divided by L equals in kilonewton per meter. Okay, so you still get 4.2 kilonewton per meter for your answer. Okay, so that's number 1. Number 2. If L is 6 meters and the shear at A is 9 kilonewtons. Now the shear at A will be equal to the reaction at A. So let's just solve the reaction at A, then we'll equate that to the shear at A. Here's the load diagram again. MA is WL square over 30, MB is WL square over 20. This RA is equal to the shear at A. Let's call that V sub A instead of RA. So what we do is we sum up moment at point B, a right end. So summation of moment at B equals 0. So we have this one, this VA is clockwise. So that's V sub A times L. The moment arm is L, this one. So that's positive because it's clockwise. Another clockwise moment is MB. So plus M sub B. Then the rest are now counterclockwise. Let's start with MA. MA is counterclockwise, so minus M sub A. And the load is also counterclockwise. Minus 1/2 of W times L times the moment arm L over 3 equals 0. Okay, so now we will substitute the values for MA and MB in terms of W and L. So MB is this one, MA is this one. Okay, so let's copy this, put it here, and then we'll substitute the values of MA and MB. So MA is WL square over 30. Let's substitute that with that. And MA is this one. And MB is this one. Okay, now we can simplify this one, solve for W, or we can just let MATCAD solve for W explicitly. We'll just use symbolic solve for W explicitly. So W equals 20 times V sub A divided by 3 divided by L. Now our V sub A, 9 kilonewtons, and length here is 6 meters. So let's copy this. That will be our W. W equals that equals, let's express that in kilonewton per meter. It's 10 kilonewton per meter. That will be letter B, this one. So number 3, if L is 10 meters, X, that's the location of the point of zero shear or the maximum moment, is 5.477 meters, and maximum moment M max is 25.727 kilonewton. Okay, so here we are going to use the diagrams for shear and moment. We know that to get the maximum moment, that will just be moment A, moment sub A, plus the area of this part of the shear diagram. Since this is a second degree curve, we can use, and since the slope here at point A is 0, that means we can use the formula for the area of a spandrel. This is a second degree spandrel, so our area will be 1/3 times base times height, or 1/3 of the rectangle. But that 1/3 is this part here. So that means this part, the shaded part, is 2/3 the area of the rectangle. Okay, so again, M max is M sub A plus the area of this shaded portion of the shear diagram. Okay, let's solve that one. Number 3. Again, it's M max equals M sub A plus the area of the shear diagram. It's 2/3 times the base, which is X, times the height, which is V sub A. Okay, so what do we know so far? MA, we know MA. So M max is M sub A plus 2/3 of the base times the height, which is V sub A. So what are given here? Length is 10 meters, X is 5.477 meters, and M max is 25.727 kN meter. And also, M sub A is this one. How about V sub A? Okay, for V sub A, because this is for W, let's copy this again. Put it here. Instead of solving for W, let's ask MATCAD to solve for V sub A. So V sub A is 3 times W times L divided by 20. Okay, this one. Okay, so let's substitute this here. But be careful with MA. MA here is below the 0 line, so this should be negative. So this is negative MA plus VA, which is this. Then we'll substitute VA with this one, Control V. And let's ask MATCAD to solve for W explicitly. Symbolic solve W explicit. Okay, so W equals this one. Let's copy this. Okay, so we have the value for M max given, this one. We also have L, 10 meters, and we also have X. Therefore, we can now have our answer equals, let's express this in kilonewton per meter. It's 12.001, or this one, 12. So our answers are letter A, 4.2. For number 2, letter B, 10. And for number 3 is 12 kilonewton per meter.